Human beings, hello. This week in Cassandra, Planet Cassandra, good times. This is our fourth week. Today we have, I believe it's pronounced Eric LeBeau from the bayous of Louisiana.
Not even
Simple
close.
Reach from
Not even close.
special guest, right? Thanks for coming, buddy. Long
I,
time no see.
I'm so excited to just hang out with you, not in person. I
Yeah.
can't even begin to explain it.
Well, I felt like we had a very nice time at the Cassandra Day LA. I had
I
a good
think
time.
we did. We
I,
did. We had a great time.
yeah, it was magnificent. And then I think you went and kicked someone in the face afterwards as part of some sort of.
No, 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 no. That was just jujitsu. That was just
Oh,
grappling. But
oh,
yes,
okay.
I did. I did train in one of the great places on Earth, at 10th Planet Jiu-Jitsu in LA. It was awesome.
Yeah, look at you. All right, so let's look at what we have for this week. First up in the blog posts, how to write a distributed test for Cassandra. Um, hey, you know what? I'm pumped about this. Luke, what do you think?
Well, so I was I like reading through Jira's and stuff. I see D-test mentioned all the time, and I knew it stood for distributed test, but I wasn't really sure. And I've noticed that pretty much anytime somebody submits a patch, one of the contributors will almost always ask for a D-test covering it. So it's kind of cool to have a how-to. If you're interested, if you're out there and you're interested in contributing to Cassandra. If you're going to send a patch, you're probably going to get asked you're going to get asked to write a D-test. So how to do it. This is nice.
I've been in the Cassandra community for like 4 years now, and I had no idea how to what that. I was like, I have no clue. Like, what is a D? Like, how do I get this? Like, I just
And
never
it's
looked.
Python. You got to be super excited about that, right?
I know.
The whole test harness is in Python.
Yeah, I'm very pumped.
I'm actually confused why, Luke, you're so excited about it, considering it's a Python.
When we did the recommendation engine for Killer Video, John and I were writing some Python code, mostly John, and then I was, trying to fix some stuff after the fact, and so I had to dip my toes in there, and I don't hate Python,
Yeah, Python's a good time, man.
I don't understand the whole Python 2 versus Python 3 holy war, but
It's just about as sensible as Perl 5 versus Perl 6 or Vim versus Max.
Yeah,
Usual works.
There's a lot of pain there. Well, there was just some things that were horribly broken in Python 2, like strings, for instance. Like Python 3, it's like Unicode strings. So the thing that they really screwed up was they actually changed how the language behaved. So like everybody's like, hey, like none of our stuff worked, and it's been like years and nobody's using Python 3. So it's very exciting.
And it's not going to change because enterprises, especially like us, who have tens of thousands of lines of Python code in production, can't just drop in Python 3 to test anything. And the drivers don't work, the libraries don't work, the programming paradigm is completely different. It's very problematic.
Yeah, I did the upgrade for when I was still managing CQL Engine. I made that compatible with Python 3, and it's like, it wasn't that it was hard, it's that it was annoying. Like, you have to use like the 6 library, which is like compatibility with like both. So instead of using like Python strings, you got to use like the 6 strings, and it like just does it for you, and you're just like,
and even worse is when you deal with other things that like people would normally use Python for. Like, one of the things that we're getting into is a bit of the graph database work, and I know DataStax is getting into that as well. And all the graph database drivers are written using Python 3, which makes it nearly impossible for anybody to work. Yeah, I've gone through all of them. They're only now being backported in the past 30 to 60 days. And that's because I'm working with a lot of the people who work on the drivers, trying to push them to kind of work with Python 2. Async I/O in Python 3 is a big deal. So,
I agree.
Welcome to This Week in Python with your host, John Haddad.
We can move on to Python.
But we digress.
Yeah, all right. We'll talk about Cassandra. You're right. How about this next post? Removing a disk mapping from Cassandra over at the last pickle. Unfortunately, I believe this dude's name is pronounced Elaine. I see it on the mailing list all the time. He posts every day, but I've never actually heard his name pronounced out loud. So if I'm butchering it, kind of the opposite of how I pronounced Eric's last name correctly.
Yeah. We can just go with Lubau, which is the right way, but, whatever you want. John Haddad.
That actually is correct.
Yeah, but I said it slow.
No. Hey, what do you think? Removing disk mapping, operations, you love ops.
Yeah, I mean, look, this is one of those things that you, as an ops guy, you kind of hope that you never have to do, but as an ops guy, you always realize that there is going to be some point at which you have to do a very annoying disk operation, whether it's on hardware, which I can comfortably say I haven't had the pleasure of working with Cassandra on actual physical hardware. I do all my operations on AWS, but this is something that hasn't been well documented. So just to be able to have a guide to follow, I think is a big deal, especially for the ops folks out there who kind of struggle through the nitty gritty of Cassandra operations.
Yeah, I noticed there's a lot of rsync going on in there. It's probably one of the best tools I've ever used. I love rsync.
Actually, if anybody's heard any of my recent talks, I actually explain what it's like to upgrade individual nodes, and those nodes, in some cases, in my case, have had upwards of 1 terabyte of data on them. And when you want to do in-place sort of swaps of nodes, you use rsync, and not just once or twice, over and over and over. Rsync the data over, shut down the node, do the final rsync, so the commit logs written to disk can get rsynced over. And then when you spin up the new node, you just double check that everything's there by doing rsync hash comparisons. CRC checks is another way of saying it. And then, yeah, it's a headache, but with rsync, it actually becomes a lot easier to deal with. So the guide that Mick put together is actually, Mick from The Last Pickle, is quite helpful.
Yep. What else we got here? Patrick McFadden. We work with him. The most important thing you need to know in Cassandra data modeling, the primary key. This is kind of like a little refresher almost. It's like first thing, just seriously, cool it. Primary keys are important, kind of matter a lot in Cassandra. Controlling how data is laid out in the cluster, how data is laid out in disk. If you're new to Cassandra, I'd say this is one of those things. Just read it, put that information in your brain. Because if you don't know it, then you probably shouldn't be using Cassandra. It's just not. It's not practical. It's not practical. I don't know. Luke, anything?
I think one of the important things that he covers here is he just does the basic. Hey, you can select by a primary key. And that's a lot of times what you're going to be doing in your standard applications is you're going to be selecting by your primary key. So knowing how to do it and knowing how to create that system is it's pretty important because your primary key selection is your fastest operation. So that should be your benchmark.
Yeah, it's accurate.
Yeah, it's just a pretty good recap of beginner stuff. If you're new to Cassandra, like you just said, definitely read it. The stuff about data locality and that kind of thing is really important to learn. So. Yep.
And we talk about that. Luke, we've given roughly 1 trillion talks on core Cassandra concepts, and that's what we talk about. We're just hey, you need to get your data by your primary key. People are like, well, how come I can't just do joins? And we're like, well, if you have 1 trillion row table and you want to have another trillion row table, and then you want to do random scatter gather across all that, it just doesn't. It doesn't compute for a lot of people until you think about the massive scale and the cost of doing secondary index queries and how you could have a 500 node cluster and only hit 1 node if you're querying by the primary key.
Right, and that's that's another very again, that's a really good way of it's talking to a developer. But when you're coming from the ops view, which tends to be the way I sort of think of things, it's I look at when developers write queries, and even if they are writing consistently primary key requests, and I see 1 node getting hit very frequently, and you can just do that very simply by looking at, disk I/O. You could see that by looking at CPU utilization, and that's when I start to say, well, how did you choose your primary key? Like, how did you choose your clustering key?
Yeah.
So it's actually from whatever side you sit on. If you're working with Cassandra, like, this is an important, not just beginner thing, but it's a good reminder thing.
Yeah, like for instance, like if like in your example, if people like were to just have like one partition for like they're like, oh, this is my leaderboard, and it's like, well, you have like one leaderboard, which means you're always going to go to the same server. So even if you keep expanding your cluster, like your leaderboard is getting pulled off the same server every time.
It's not going to help spread the load, right?
Yeah.
Right.
No spreading.
I can give you a very specific example because we did something similar. We're at Simple Reach, we're an analytics company, and one of the things we do is collect web traffic. We collect web traffic data, and we decided initially that we were going to store all raw events in one table, but segmented by hour. And that was a really early mistake because that meant that for 1 hour, every single piece of traffic that we saw got written to the same node, and then it would move. And we were like, why is this happening? Well, we didn't really think through that it should be like a compound key of, say a URL and then an hour, because that just means that one URL will peg a node for that 1 hour, and then it'll move to let that node calm down and catch up and be eventually consistent.
Yeah.
And all those other good buzzword terms.
And that's an easy mistake to make, right? Because in your case, like you're talking about a set of parentheses can change the key and completely change the behavior of an entire cluster. It's like a set of parentheses can literally like mean either you did it right and everything is awesome and you can use like a 100-node cluster, or you did it totally wrong and you're just failing big time.
Well, that's exactly what happened. Is we were working off of a 12-node cluster, and we couldn't figure out what happened, what was going on. So we bumped it up to 30 nodes, and we made the node sizes larger. And we're like, we can't continue to operate like this. And we called in one of your fellow DataStax folks at the time, Tuption Harper, very smart fellow, and he just showed us that we were missing parentheses, and this would be a lot better. And we turned our 30-node cluster back down to 6. It has since grown to 70-plus nodes as the company has grown, but just that one slight parenthetical mistake, more than doubled the size of our cluster. So understanding those keys it's a beginner thing, but it's also incredibly important for growth because it's very difficult to change and migrate your data later.
Yep.
It's the difference between needing to know beforehand what your schema should look like and trying to change it post facto.
And this is actually kind of interesting. This is a case where doing like stress testing with a real cluster makes a huge difference. Like people sometimes only benchmark against like a single node. Like on my laptop, I'm like, hey, I'm just running one Cassandra node, and that's an easy mistake to make because you wouldn't necessarily see the effects of how your key affects the distributed environment if you're only working on your laptop.
So to actually tail that, I believe on your side, Jake Luciani wrote an update to Cassandra Stress that has a schema base to it now. So you can actually put in your schema, spin up a cluster, whether that's on CCM, the Cassandra Cluster Manager, or putting it somewhere in AWS, whatever it is. You can spin up a cluster with your schema and hammer it and see what happens. Even if it's just a 3-node cluster. So there are tools out there to test your assumptions, even in a distributed fashion.
Mm-hmm. And I love breaking stuff in a distributed fashion. So, so let's take a look at these JIRAs that have been updated because there's a couple more that I definitely want to look at here. Allow custom tracing implementation. This just got merged into Trunk, and I am ludicrously excited about this. Like maybe overly excited. Like at first glance, you're probably like, why does he care so much about this? I think it's huge.
Yeah, you and Eric both sounded pretty excited about it.
Yeah.
Oh, absolutely.
Yeah.
I mean, I have a system I have an infrastructure of hundreds of nodes. and it works with message queues. It works with message processing that gets passed in between different applications, consumers and producers. And we had to write our own tracing system because there wasn't really something like this at the time. And we wrote our own tracing system that involved like injecting changes into messages and then reading them at different points. And we wrote our own receiver, which is effectively like just ingesting data, turning it into JSON and Mongo, and then we had to build a front end for it. Look, we did it with Mongo because it's just easier to write. We weren't sure what the schema was going to look like, so we ended up having to make a bunch of changes before we got it right, and then ended up dropping it altogether because it was taking us too long outside of building our own application. But having something like Zipkin and having it tied to Cassandra, which we already use, and having an interface for it, which already exists and we don't have to write, is absolutely phenomenally exciting for somebody who runs distributed systems.
Yeah. So let me add a little background to this.
Yeah, please.
So the custom tracing implementation, the inspiration here is adding Zipkin support into Cassandra. So Zipkin comes from Twitter. It's Apache licensed. And it's an open source implementation of a paper that Google put out about their infrastructure tracing system called Dapper. And effectively, in a distributed system, as Eric mentioned, you can have hundreds of nodes. It's really hard to figure out like where performance problems are. Like in a request, if you hit 50 nodes over the course of that request, it's really hard to find the exact point at which something is broken. And what Zipkin does is it gives you the ability to trace a request throughout the entire system, and now we'll be able to trace it through Cassandra. So that's going to go into Cassandra 3.4. So this is really, really cool in my opinion. If Zipkin is integrated into your application, it's integrated into Cassandra, and it's all your databases and tools that you use, you can get a really cool profile of what's happening in your app. So I'm a huge fan of this.
And performance bottlenecks. I mean, I know you sort of alluded to it, but if one of your applications that's a processor, for example, starts slowing down, you're going to notice it when you see, if you have no tracing in place, you're just going to see the time the message starts at your infrastructure to the time it ends takes, say, 7 seconds. I'm just making up numbers. And if all of a sudden it starts taking 10, you're not going to know why or where that happened, and then you're going to have to trace every single piece of the application by hand. And what Zipkin allows you to do is basically say, hey, guess what? I think that's probably between this point, and this is why, because our average delta for this message was 600 milliseconds, and now all of a sudden it's 1400 milliseconds.
Yep.
So that's the power of this, of having something like this available to you.
Yep. It can help you narrow down problems more quickly, and I know you're a huge fan of just having metrics and information about your infrastructure.
Absolutely.
Yeah.
And as an ops guy, that is one of the rules. And if you talk to most ops guys, they will say a service or application does not exist unless it's monitored. Yep. And this is a way of monitoring and instrumenting an infrastructure that is very tightly coupled to the way information flows through your infrastructure, which is very difficult things for most developers to conceptualize, but having a system that sort of understands it just because it gets plugged in along the way is incredibly valuable.
Yep.
From a developer's perspective, I can just even thinking back to like one of my previous jobs, like having that information available, it could be an ops problem that's causing your latency or your message processing time to go from 600 milliseconds to 1400 milliseconds, or it could be a code change, right? And if you can point a developer to, hey, it's this particular part of the system, or it's this, in this day and age, everybody's doing microservices, so it's this microservice, or it's this, piece of the system. It's way easier as a developer to go and try and find the problem, or to narrow down, the change that might have caused the problem. So,
and Yeah, and having the metric behind you it's a lot easier to have a conversation where you're like, hey, I have a metric and it shows that this thing is slow versus, hey, your microservice is slow, and then it becomes like a personal battle. People get like defensive about it. Like, so,
Yeah.
people are like, what are you talking about? I didn't, like, it's not me, obviously. Like,
Yeah,
I'm
people get defensive about the code they've written. Yeah.
Yeah.
Yeah,
I do.
and the cool thing is that it might, and to your point, Luke, it may have nothing to do with the code itself, but the code may help diagnose a problem in, say, the database related to that service, right? And like that, just having just understanding the structural integrity of your system through something like tracing it's mind-blowingly easier to diagnose problems.
Yep. And being able to see, like, even within the microservice, that a particular query took a long time, and it's like, you can like look at the high level, or you can like really drill down and see it at a really detailed level. So, like, the amount of information that you can get out of this is incredible. The time savings, huge. The fun, off the charts. Love it. All right, let's go. We got support for group by in the select statements. Boom. You know what? Dropping the hammer. Cassandra open source. I'm excited to see aggregations in here that are more evolved than the UDAs that have been added. You don't have to write Java for one or whatever. So yeah, this is happening. This is being worked on right now. I'm on this Jira at the moment. Get pumped.
I mean, I think for me, I'm really interested to see what this. I think this is a game changer, but it really just depends on speed. I definitely would like to see some benchmarks when it's done. Not like I'm trying to be a hater or anything. I just think it's important to understand like what potential trade-offs you're making when you get something powerful like group by. Wide rows are one thing, but once you talk about beyond that, are the group bys using the SASIs properly? Which I know is one of your favorite topics, John.
Dude, well, so here's the thing: is I'm not 100% on this, but I think that you're limited to single partitions. So you're not going to be like, give me the whole database, like let's just group on whatever. Like you'd be looking and you'd say, okay, I can either take back like 10,000 rows out of this partition and aggregate it in my application, or I can let the database do it and not transfer everything over the wire. So At that point, you're looking at network savings. And the question is, can we aggregate fast enough in Java? Probably.
Probably.
Yeah.
It looked like that was being debated, though, in that ticket, like whether or not...
which is why that's exactly why I brought it up.
Across partitions or not, like whether it was going to be required that you had to provide a value for a partition key to narrow it down, essentially.
Yeah. So that'll be a good one to watch. And that's Cassandra 10707. This is all in the blog post, so definitely read the blog post, follow the link. Don't listen to me. And the return of diagnostic tools, SS table dump, replacing SS table to JSON, which I know your coworker is a huge fan of, right?
Yeah. Russ Bradbury is a big fan of this SS table to JSON. See, one of the things that I think it's important to understand when you build systems that are larger than just one or two machines is having a standard communication medium. So whether that standard communication medium is XML, which I guess would be great if you don't like yourself very much, or JSON.
You love to cry.
Yeah, you love to cry. Any one of those things. But JSON is typically a standard form of communication, and so what it allows you to do is create applications in any language, and allows your developers to be efficient and say, hey, look, I want you to process this data in whichever form is easiest for you. And let's just double check what we have. Let's create a materialized view for ourselves. Whatever it is, you're working with a standard set of tools. And SS table to JSON is a thing that actually allows that to happen. Whereas SS table, the original version, when you had JSON in Cassandra and then tried to dump it, it made it very difficult to process.
I think I'm going to write a tool that takes the SS table dump and then puts that data back into Cassandra so you can analyze it using Spark.
That's actually exactly what we do.
Really?
We SS table dumps, and then we turn them into a form that can be processed by Spark.
Yes. I love when my like outrageous idea. It's like, no, we're actually doing that. We're totally analyzing our SS table data with Spark.
No. Sorry, we're not analyzing the raw SS table. We're rewriting some of the older style data
Right.
as we need it in a form that's much more conducive to Spark queries.
Okay, gotcha.
So it's very custom, and I otherwise I would say we'd happily get it out there, but it wouldn't work.
Yeah. All right.
Still feel free to write your own.
What's that?
Still feel free to write your own.
I will. So it looks like we've got our Jiras out of the way. Hey, Eric, are you guys hiring by any chance? Maybe you're hiring.
That's funny. You should mention that. Actually, we are hiring here at Simple Reach. So I've already told you guys a little bit about the size of our infrastructure. But what we're looking for is just a back-end engineer, somebody who likes writing Python, who likes writing Go, and that's Python 2. I know we talked about it, but Python 2.
Deuces.
And we're looking for somebody. We have a distributed team, so wherever you are, if you like working with large amounts of data and you might like working with me and Russ, the other author of the book Practical Cassandra, then reach out. The link is in the blog post.
Mm-hmm.
Shameless plug. Finish.
Hey, I was wondering. I was like, maybe I like Python. All right, cool. There's more stuff in the blog post. I think we're gonna wrap it up for today, though. We've got some CFPs that are open for analytics and Python conferences. Some meetup information that's in here. So definitely check that out and go to your meetups. It will make Lena happy. If you don't know Lena, she is our community wrangler, cat wrangler, if you will. She's very good at making this stuff happen. So huge thumbs up. Let's see now. Anything else? You guys have anything?
Nada.
Nothing?
No.
All right. Okay, cool. Well, we're done. Thank you very much. All right, later. Shut it down.